Welcome class. This is our third lecture on properties of Laplace transform. In the second lecture, we have studied about two properties. One was our shifting property and another was our time differentiation property. So these were the properties. Laplace transform of e to the power at ft is equal to f of s a minus a. This was our shifting property. And we also learnt about time differentiation property. And we have also done two of the questions on this topic. Now we are going to derive other properties. If Laplace transform of ft is equal to f of s, then Laplace transform of ft by t is equal to s to infinity f of s ds. This is the third property. Fourth property, that is going to be if Laplace transform of ft is equal to fs, then Laplace transform of 0 to t ft dt is going to be f of s by s. Fifth property is going to be if Laplace transform of f of t is equal to fs, then Laplace transform of f of at is equal to 1 by a f s by a. And the sixth property that we are going to take up is Laplace transform of f of t minus a ut minus a, where ut minus a is a unit step function. Then this is a transform. We are going to take up one by one. First, we are going to take the third property. These are the properties we are going to study. Third property, if we are here to prove this one. If we take f of s, that is 0 to infinity, alright, and e to the power minus st ft dt. Now we take the derivative of this, or we have to take the integral rather. So if we integrate it from s to infinity f of s ds, because we are working from the right hand side. We have written f of s as the definition of Laplace transform. Now we are integrating this from s to infinity. Similarly, we are going to write it from s to infinity, 0 to infinity, e to the power minus st ft dt ds. Now we are going to change the order of integration. When we are doing so, we will take 0 to infinity, and that becomes ft dt. This becomes 1, and another one is s to infinity, e to the power st ds. Okay, we are just going to integrate this equation. So what it becomes? It becomes 0 to infinity ft dt. If we integrate it, what it becomes? E to the power minus st divided by minus of t, and our limits are s to infinity. Okay, and we close this bracket. So what we got? 0 to infinity ft dt. Alright, now if we put the limit, what it becomes? E to the power minus infinity, that is our 0. So this becomes 0. Again, minus of minus minus become plus. So what we get is e to the power minus of s t, and t remains the same thing. Alright, so what is it? It becomes 0 to infinity f of t e to the power minus st by t dt. So this is again simply the Laplace transform of ft by t. So we can write over here as this is the Laplace transform of f of s ds is equal to Laplace transform of ft by t. So we have just now proved this equation. the third one. Now it is pretty much clear. Now we are going to prove the fourth property. Fourth property, what we do is that we are going to take this 0 to t, ft, capital Ft, is 0 to t, f of t dt. Now, if we take the derivative of f dash t, this becomes f of t by Leibniz rule of integration. And if we take capital F of 0, this becomes 0, 0, f of t dt, that becomes 0. Now, we are going to apply the Laplace transform of f of t. That becomes 0 to infinity e to the power minus st f of t dt. So we are now going to use the integration by parts. So that is going to be e to the power minus st divided by minus s f of t. This is infinity to 0 minus become plus e to the power minus st divided by 1, and this is integral again 0 to infinity, and this become f dash t dt. Alright, now we are going to put the limits over here. So what this becomes? This becomes e to the power minus infinity again 0, so this one becomes 0, and f of 0, as I have written over here, is 0. So this whole become 0 minus 0. So what this become? This become 1 by s 0 to infinity e to the power st. And what is capital dash t? Capital dash t is ft. So the moment we write it, what it becomes the Laplace transform of f of t, that is capital F by s. So this is our claim, and this is what we have proved. So we have proved the property number 4. Now we are going to prove property number 5. Property number 5. Property number 5 is f of at. We will simply put into the definition 0 to infinity e to the power minus st f of at dt. So what we do, we put at is equal to u. That means dt is equal to du by a. Now when t is equal to 0, we can say u is equal to 0. When t is equal to infinity, u is equal to infinity. Now we are going to put it in this equation. So what we get? 0 to infinity e to the power minus st. So in place of t, what we get? U by a. And here what we get? F of u du by a. So what we get? My 1 by a is outside, and 0 to infinity e to the power s u a f u. Now we have always claimed whatever be the coefficient of u, that is going to the transformer, that is s by a minus u. So this become 1 by a f of s by a. So this is what we have claimed, and this is what we have proved. And the last one is this property. We are going to prove it right now. I will erase the upper parts also, so that I can solve it. So the property is Laplace transform of f of t minus a, u of t minus a is equal to e to the power minus s f of s. Alright, this is the property. Now before that we must know what is UTA minus 1. So UTA minus 1 is a unit step function, which is 1 for t greater than a, or 0 for t less than a. So if we try to plot it over here, we can say this is a. So from a, its value is 1, that is unit step. So this is 0, this is your t, this is u of t minus a. So what is the Laplace transform of f t minus a, u t minus a? We put into the equation. What is that equation? est f of t minus a, u of t minus a dt. Alright. Now we will bifurcate it from 0 to a and a to infinity. So what it becomes? E to the power minus st t minus a u of t minus a dt. E to the power minus st f t minus a u of t minus a dt. Now from 0 to a we can readily see, from 0 to a the value is null, that is 0. So here this becomes 0. Now from a to infinity, that is from a to infinity, the value is 1. So this value becomes what? 1. So finally what becomes the integral? Integral becomes a to infinity e to the power minus st f of t minus a dt, because this is 1. Now if we put t minus a is equal to u, what we get? We get t is equal to a plus u. What we get? dt is equal to du. Now when t is equal to a, u is equal to, we put a minus a, 0. When t is equal to infinity, what we get? U as infinity minus a, infinity. Alright, now we are just going to put what we have got. So u transform to 0 to infinity. What does t becomes? T becomes a plus u, alright, a plus u, and t, a minus becomes u, and what does our dt becomes? Du, without any differentiation. So if we take e to the power minus as outside, 0 to infinity, e to the power minus su, fu, again this is the Laplace transform, u, and the coefficient of minus u is the transformer. So this becomes e to the power minus as f of s. So this was our claim, and this is what we have proved. Alright, now we are going to take up an example asked in civil services examination based on this property. The question is, log of 1 plus 1 by x square plus s by s square plus 25 e to the power minus pi x. So this is asked in Civil Services 2015. Now this one and this one, they require different properties. This one we have already discussed in the previous lecture, where we have studied about the time differentiation property, and this will require the use of this property, t and ft dt, and this one is t minus a ut minus a, this property. So what it is, whatever property we have studied, it demands us to apply those properties. So we will take it one by one. We take this one as f1 of x. So what we get, f1 of x is s square plus 1 by s square. So this is s square plus 1 minus 2 of ln s. We will take this derivative. So what its derivative is like? Its derivative is x s square plus 1 2s minus 2 by s. Alright. Now we will take the minus sign for the obvious reason. So what minus sign is going to be? 2s by s square plus 1. So we know that minus of f1 dash is equal to Laplace transform of t of ft. So if we just invoke the inverse Laplace transform of this one, what we get? We get the inverse Laplace transform over here is t ft dt. Just invoke inverse Laplace transform. What it is? 2 cos t. So we get ft1 is equal to 2 1 minus cos t by t. This is perfectly done. So we have done with f1x. What about f2s? Alright. So we know this is f of s is s square plus 21. So this is, if we invoke its inverse Laplace transform, this is cos 5t. Now we have this e to the power a s. So what it was? The function was like this: u t minus a is e to the power minus a fs. So we have the fs. we have the ft. Here a is minus pi. So what we will get finally at this inverse is cos of 5 t minus 5 u of t minus 5, because we are using this property. So this becomes minus cos 5 t u t minus 1. So the final answer is 2 1 minus cos t by t minus cos 5t u t minus 5. This is the answer. So with this we end our lecture, and I would like to thank for watching. I would like you to share and subscribe, and so that it could reach to many people, and thanks for watching.